Okay, continuing with just calculating inverses. Start by switching x and y. Solving for y, we need to square. Okay, so the inverse, and this is called h, so h to the negative 1 of x is going to be x squared minus 3 all over 2. You could write it as x squared divided by 2 minus 3 halves. X, y, z will take either. It says give the domain of h prime of x by looking at the range of x. So what I did was I wanted to do this kind of quickly, and I plugged the original function 2x plus 3 into the graphing calculator. And notice that it is just a left-right translation, okay? So if I'm looking at, so this goes left-right, and I've got a point in here somewhere around, it looks about a negative 1/2, yeah, so negative 3 halves, right? And y equals 0. So that means that my inverse is going to have a point at x equals 0, y equals negative 1/1/2. So my inverse is going to do basically that. So if we look at, all right, so let's take a look at the hint they gave us, which is to look at the range of this function. Well, the domain, we don't care about the range. It looks like the range is y is going to be greater than or equal to 0. Okay? Well, that's going to be my domain on the inverse. So the domain of the inverse is going to be x has to be greater than or equal to 0, or 0, infinity in interval notation. Okay, last one. F of x equals the square root of x minus 1. So x square root of y minus 1. So x plus 1 equals f to the minus 1 of x. All right, on to the last couple of problems here. This problem is easier than it looks. First thing they asked us is find f of 2. So we're going to go to x equals 2 and pick up that y value. The second one asks us to find the inverse of f to the minus 1 of 2. So what we're going to do is we need to look for a point where y equals 2. So if you look at all your y values, we get to that one. And because x and y switch on inverses, f to the negative 1 of 2 is going to be the x value that's given in that point. Okay, last thing I want to talk to you about is the temperature problem that's given. I'm not going to do this problem, but I am going to get you started. Okay, I brought it up because it's the same problem. And what it does, it says, and again, we got to talk, we're working on inverses. We're working on inverses of, linear, quadratic, and that seems like about it. But what they do is they give you a couple of points. If you're looking at, and we're going to look at, they give us, when measuring temperature, 100 degrees Celsius is equivalent to 200 degrees Fahrenheit. So they're giving us these points in CF form. So 100 degrees Celsius is equivalent to 212 degrees Fahrenheit, and 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. So if they're asking you for f of c, okay, that means that you're going to calculate the slope, and you're going to use f of 2 minus f of 1 over c of 2 minus c of 1. And what I'm talking about is f1, c1, f2, c2. I know I could call them x's and y's, but they use f's and c's throughout this problem. I think it's probably a good idea to start with that. Once you get that done, once you get the slope calculated, then you're going to find the equation of the line. Now, I'm going to use a variation of this, but I'm going to change my y's to f's and my x's to c's. So f minus f1, or you could use f2, equals the slope you calculated in the previous step times c minus c1. And once you plug in the first point, f1, c1, then you're going to have an equation that you can solve for f. In order to find the inverse, you just find the inverse of that equation you found in this step. Hope that helps. And I will see you guys in class.